Which ionic equation represents a redox reaction? So we have multiple ionic equations. Over here, what is the charge on Ag and Cl? So AgCl is an ionic compound, and the charge on silver is going to be plus because I know for sure the charge on chlorine is going to be minus. Why do I know it's minus? Because it's a group 7 bonded element, right? So it has to be -7. So it's coming from ionic form with plus and minus and still stays like that. So this is not even a chemical reaction at this point. If you're a little more aware about this equation, you'll realize this is an aqueous ion just drying out, right? And turns into a solid because why not? So it's not even a chemical reaction. Similarly with B, exact same thing is happening. Same two ions form together, nothing's happening. C, now you're making water, it's a compound, but the idea of oxidation states, how they're exchanged, still remains. So we've spent multiple times calculating the oxidation states of oxygen and water, hydrogen, and we know it stays positive and -2 for oxygen. So to the point where, you know, when we have to calculate the oxidation number, we just don't even bother with water because we know hydrogen will always be +1 and oxygen will always be 2-. We just remember it at this point. The last one is pretty clear. So copper, we see it has a 2+ charge, and over here now it's changing to a 0 charge. So that's a gain of 2 electrons. Gain of electron is reduction. We identified that. And obviously the opposite, the other thing, only thing left has to be oxidation. And clearly the charge is increasing from 0, it's going to +2. So it is being oxidized. This is a redox reaction. Your correct answer is D. The equation shows a redox reaction between iron 2 chloride and chlorine gas. Iron 2 chloride is already telling you the oxidation state of iron, because the Roman numbers tell you the oxidation state of whatever is before it. So transition elements, you'll always see almost, if they have variable oxidation states, they'll have a Roman number in front of it. Iron 2 chloride, iron 3 chloride, which highlights not the number of chlorines or iron, but it highlights the oxidation state of iron, right? So which equation describes the reduction process in this reaction? So what we can do is, there are two elements which are undergoing a reaction. Let's make two equations. So focusing on iron, it has a 2+ charge turning into a 3+ charge. So let's write that down. For iron, that is Fe2+ turns into Fe3+, and it's losing an electron. I keep writing 2, losing an electron. For the second one, chlorine, it's in its elemental form, so I'll just write Cl2. Sometimes people will write just Cl, especially for electrolysis, they'll just write Cl atom, you know, Cl, but Cl2 makes more sense. Gains 2 electrons to form 2Cl-. Okay, which equation again describes the reduction process? Reduction is gain of electrons, chlorine is gaining electrons. So I have to find this equation in my options or something very close to this, but you know, B is exactly this equation. I was told that sometimes you put a minus sign over it just to, you know, that's the only difference between the equations. So I put a minus sign, it's identical. Do you need to put the minus sign? I personally hate it. Moving on. In which reaction nitric acid is acting as an oxidizing agent? So nitric acid, how you want to see nitric acid is it's HNO3, but the nitrate part is just 2-. Think of this as one thing and your life will be a lot easier. Then you have H+ on the other side. If we start doing that, let's look at the first one. Okay, the other thing about the first one is copper is in its elemental form and it's turning into a compound form, so definitely something is happening, right? So copper has a charge of 0, and over here it'll have a charge of 2+. Why is it 2+? This is copper nitrate which is made of 1 copper and 2 nitrate ions. 2 nitrate ions. All of that is equal to 0. Similarly, how we did it for everything else. Copper has a charge of +2, and each of the nitrate ions has a charge of -1, so that's still equal to 0. Sorry, I wanted to find this out, so I jumped the gun and answered it for you. But we're trying to find out the charge on copper. Cu comes out to be +2. So this is +2. We clearly see it's being oxidized. So if copper is being oxidized using the nitrate ion, because that's helping it, right? Because it reacted with it. So that makes nitrate ion an oxidizing agent, right? An oxidizing agent is essentially a chemical that reacts with something and oxidizes it, and in turn it itself will get reduced. That makes complete sense. So erasing this, let's go over the rest of the examples or options. In B, we see that the charge is not changing for anything. Nitrate ion over here has a minus charge, over here still has a minus charge. Hydrogen, hydrogen, water again, right? Copper is 2 plus over here. Copper, you'll realize, because of the -2 oxygen, is also 2 plus. B is out. This is a complicated equation and I didn't feel like doing it, but clearly you can see that the nitrate ion is coming over here to the sodium, so that still holds true. Nothing is really changing. The only thing that is kind of tricky is CO3 is turning into CO2 and losing an oxygen, but we've soon, if we do some math, realize that nothing is really happening to the carbon over here and is just going out, and it's not being oxidized or reduced. D is neutralization, because it's a base, sodium hydroxide, reacting with a very not so famous acid, nitric acid, to form a salt in water, and all acid and base reactions are non-redox reactions, right? And we can prove it. Sodium is +1 over here, OH is minus, and sodium is +1 over here. OH part of this is -1, hydrogen over here is +1. This is again -1. This is, yeah, you get the gist of it. The correct answer over here is A. Moving on. Which statement does not describe a reduction reaction? Electrons are gained during a reaction. That's literally rig of our oil rig. Reduction is gain of electrons. Hydrogen is gained during a reaction. I was confused about this. Hydrogen being gained, hydrogen has a positive charge. So anything gaining hydrogen, yeah, I keep getting confused. So this is how I remember it. You have oil, oxidation is loss, rig, reduction is gain. But another way of figuring it out is oil is also gain of oxygen. So reduction has to be loss of oxygen. If oxidation is gain of oxygen, it has to be loss of hydrogen as well. Why? No particular reason. That's just how I remember it. This is gain of hydrogen, right? So with that said, I'll quickly write this down and I'll just match it. This is what I do. This takes me 10 seconds to write down in a less neater fashion. And I'll just write it down and say, okay, hydrogen is gained during a reaction. In reduction, it is gained? Yeah, okay, it is gained. So that's how I do this problem. And that is also a redox reaction. So that's out, because we're looking for not the opposite of, or like a false statement. It takes place at the negative electrode during electrolysis. So electrolysis, negative electrode has a negative charge and a positively charged ion will be attracted to it. So that's going to be Cu2 plus being attracted to 2 electrons to give you Cu. And that looks a lot like reduction to me. So that's also wrong. So we're left with D, and it's pretty straightforward. Gain of oxygen is actually just oxidation. It's in the name, right? So our correct answer is D. Which of the reaction is not a redox reaction? Calcium carbonate reacting with calcium oxide and blah, blah, blah. We see it breaking down, and we saw carbonate and carbon dioxide relationship. They're not really a redox related reaction. Calcium over here, I see, is not changing its oxidation state. 2 plus over here, 2 plus over here. So A is our answer, right? But let's go over the rest of the options and like be confident in it. B and C are clearly out because one hint I gave everyone in class was any elemental compound reacting with and forming into any element, not an elemental compound, any element reacting and forming a compound is always a redox reaction because it goes from 0 to something. That's redox for you, not reduction. Has to be a redox reaction. I see 2 elements and those 2 elements are not elements anymore. Womp womp, it's a redox reaction. D. Now D looks like a tricky equation, but the 2 ways of doing this, one, the easy way, which we can do right now, is to realize that this is a very famous equation which we study in metals, known as the reduction of iron, right? If you don't know that, if you take a closer look at iron, and over here you don't even have to calculate, you see oxygen is being lost from the iron, right? This is how iron is manufactured. This is the equation for it. Oxygen is being lost from the iron, so this is being reduced. Iron is being reduced. So this is a redox reaction as well. The correct answer to us is A again.